Hello, welcome to this video tutorial all about how to solve quadratic equations. Those of you that don't know, a quadratic equation is very similar to a quadratic expression such as this, but so this is the expression. The equation means that we need a zero, sorry, not a zero, an equal sign, and this could be equal to y, but more often than not we substitute the y for a zero to say that's how we'd like to solve the equation. We want to find the x values which make this whole expression equal to zero. The first way, there are four ways to do this, to actually solve this. I'm going to show you the first way, which is factorising now. Factorising just means factorising the quadratic expression part first, i.e. this bit here. Not going to go into the depths of how to actually factorise because that's on another tutorial, because this is more to do with how to solve the actual equation rather than factorise, but factorising is just a method. So those of you that do know how to do it, you can check it yourself if you wish, but it factorises to x plus 2 brackets x plus 3. Now with factorising, we've got two brackets here and they're timesing each other. If you remember, multiplying out brackets or double sets of brackets is just a product of these two brackets here. Now what this means is that we've got essentially a number inside the first bracket, depending on what you call the value of x. If I called x 10, then the number inside the first bracket would be 12 because it's 10 plus 2, and the number in this one would be 13, but obviously 12 times 13 doesn't make 0, so x being 10 is not the solution, unsurprisingly. So the point is we've got these two brackets, they're number 1 and number 2 of brackets, and they're timesing each other, but they need to be equal to 0. So one of those brackets has to be 0. So we'll either say this one is 0 or this one is 0 because something times 0 makes 0. So one of those numbers has to be 0. Hopefully that makes a bit of sense. So we can either say the first one's equal to 0, i.e. x plus 2 equals 0, or the second one equals 0, x plus 3 equals 0. Now there are two solutions to this, hence why we do both of these brackets equal to 0. So in this one, if we just say that x equals minus 2, because we remove this plus 2 by taking away 2 from both sides, hopefully you're happy with that concept, and then the second one is x equals minus 3. So we've got two solutions, x equals to minus 2 or x equals to minus 3, and that's how to solve one of these quadratic equations using the factorising technique. Just make each bracket equal to 0 and then solve for the value of x. Okay, so that's the factorising technique, as I just said. The next technique is using the formula. So I'll just write up a new quadratic equation. So there's a new one, and the formula says that x equals minus b plus or minus, I'll get to that in a minute, b squared take away 4ac all divided by 2a. And you might be thinking, what's all this b's, a's and c's? I don't know what they are. Well, it's nice and easy to understand, because if you've written your quadratic expression as x squared, then the x and then the number, then this is the a, this is the b, and this is the c. So the a in this case is 4, the b is minus 5, don't forget to attach the sign, and the c is minus 7. So all we're going to do is use these values of a's, b's and c's in the formula. And this plus or minus, we will get to that right at the very end, but just work with it for now. So x equals minus b. Well, b is minus 5 in this case, so that's minus 5. Minus 5 is just the same as a positive 5. Okay, hopefully that makes some sense. Plus or minus b squared, which is minus 5 squared, minus 4 times a. So a is 4, so minus 4 times 4, and then c is minus 7. And then we've got divided by 2 times a, so that's 2 times by 4. Okay, so we're just going to simplify this and just work with this for a bit. So 5 plus or minus 5 squared is 25. 4 times 4 is 16, so that's minus 16 times minus 7, all divided by 8. So again, simplify this a little bit. 5 plus or minus 16 times by 7 is 112. So 25 minus 112. So 16 times minus 7 is minus 112, and we've got this minus at the front there. So this bit just simplifies to a plus because we've got a double minus again, and then divided by 8. And next step, just simplify this whole square root bit. So 25 plus 112 is 137, and the square root of 137 is 11.7. So we say plus or minus 11.7, and we're dividing by 8. So now we've kind of simplified all this down by working with the numbers. So now we get to the bit where what's this plus and minus. Well, if you remember back in the factorizing technique, we had two answers. Well, we also need to have two answers from the formula, and the two answers come from either using a plus or a minus at this stage. So let's do the plus stage, which is 5 plus 11.7 over 8, and that equals 2.1. And then the minus answer is 5 minus 11.7 divided by 8, and that equals minus 0.8. So these are the values of x that satisfy 4x squared, take away 5x, take away 7, make it equal to 0. Okay, another name for doing this is called finding the roots. That can be quite useful. Finding the roots of a quadratic equation means finding all this out. So you can either use the equation or the factorizing, or the next step, which is completing the square. So completing the square, just get rid of this. That will do. Completing the square. Well, what is completing the square? Well, completing the square, or CTS, means starting off with an equation. So 0 equals, let's just do, what should we do? Oh, we'll do another one. So 5x squared minus 25x take away 14. It means we need to get it into a format that is a plus b squared plus c equals 0. Okay. Now, so we need to get this bit in this format. So how do we do that? Well, to start off with, we'll just this whole thing out, and we get to a stage where we can then compare some numbers. So I'll just multiply this out first by multiply x plus b squared, which x plus b squared x plus e times by x plus e. So when we multiply that out, again, I'm not going to go through how to expand a double set of brackets, but what we get is x squared plus 2bx plus b squared, and then we've got that plus c equals 0. Again, we'll multiply the a out, so we get ax squared plus 2abx plus, we'll just keep that as an x, plus ab squared, and then plus the c equals 0. Okay, so at this stage we can now compare. Remember, the key point, we always want to get back to this format, but this whole process of expanding this out is quite useful, and I'll show you why. Because now we've got this whole thing here, and we can compare the numbers from the question that was given to the format that we need, i.e. the a's and the b's and the c's. So the x squared term, this ax squared, is the only x squared term here, because we got this is an x term, and these are number terms because they've not got any x's in them. So the x squared term is ax squared, but in our question it was 5x squared, so a has to be equal to 5. And if we look at the x term, this minus 25x has to be the same as this 2abx. So that means that minus 25 has to be 2ab. So we can say 2ab equals minus 25. And because we know that a is 5, I can say that 2 times 5 times by b, i.e. substituting the a for 5, equals minus 25, which makes 10b equal to minus 25, and then b is minus 25 divided by 10, which is just minus 2.5. And then the last term, minus 14, has to be what's left over, because ab squared plus c haven't got any x's in them, so this whole thing here must be minus 14. Okay, so ab squared plus c, and I'm just going to use the a's and b's, so I found the a and the b there, so minus 14 equals 5 times minus 2.5 squared, and then plus the c, and minus 2.5 squared times by 5 equals 31.25, so minus 14 equals 31.25 plus c, and now we're just going to find out the value of c by doing minus 14 take away 31.25, which equals 45.25 minus. Okay, so minus 45.25. Okay, so here we've got the values of a, b and c, and if we remember, and I'm just going to move this over actually, if we remember the format that we wanted to get it all in was this, where are we, this bit here, the ax plus b squared plus c. That's the format that we need it in to complete the square. That's the whole idea of it. It can seem a bit convoluted, but generally if you remember this format and this format, then it can really help in finding what those A's and B's and stuff are. So I'm just going to get rid of some of this. So we know that we found out C, we found out A and B, so I'll put all the A's, B's and C's over here. Okay, and now we're going to take this format and just use the A's, B's and C's and just work it out. So we've got 5 x plus minus 2.5, so in fact we could just write that as a minus 2.5 squared plus c, which was minus 45.25 equals 0. Okay, and now all we're going to do is solve for x by rearranging all these good bits and bobs here. So 5x minus 2.5 squared equals 45.25, just moving that over. Divide 3 by the 5 first, so x minus 2.5 squared equals 9.05. You can check that on the calculator if you wish to. And now we're going to square root. But something interesting happens when we square root. We get square root of 9.05, which equals 3.01. But it can also be minus 3.01, because minus 3.01 times by minus 3.01 equals 9.05 as well. So basically we get, similar to the formula, we get a plus and a minus. So we say or, and that's where we're going to get the two different answers. So now we say x minus 2.5 equals plus 3.1, or x minus 2.5 equals minus 3.01. And now we're just going to find out the answers for both. So minus the minus 2.0, the positive 3.01 case gives us an answer of 5.51. Okay, and then the minus 3.01 answer gives us a value of minus 0.51, and there we get our two answers. So it's quite a long-winded way of doing it, not that common, but it's definitely useful to know, and you just follow those steps. Remember this bit up here, the ax plus b squared, the format that we want it in, and remember this bit, or if you don't want to remember that bit, you can just expand it every time and just compare the coefficients or the numbers in front of the x squareds and the x's with the actual question that we get there. If you need any more practice of that, ask your tutor. But at this time we're going to move on to the very final method of solving a quadratic equation, which is using graphs. Okay, so using graphs. We'll do a fairly simple quadratic, which is x squared plus 5x plus 6. We've done that right at the start, and if you remember, the answers were -2 and -3. That's what we got from the factorizing method. Okay, so using a graph basically just means we're going to plot it all. And you can plot the graph by saying, here we're going to write a table of, in fact I'll do it over here, of x's and y's, hopefully a bit neater than this. For the x's, we'll start off with, I don't know, say something like -5, -4, -3, -3, -2, -1, 0, and then 1, 2, 3, 4, 5. And then we'll just pop the x values in here and then the corresponding y values, and then what will happen is that you can find the all the coordinates, and then we can plot them on the graph. And what happens is that you'll end up plotting some, so let's plot a few actually. So the -4 squared, and then a -20, and then +6. So then what happens is we get these coordinates that we're building up, and for the purpose of this I'm not going to fill out the table, just for time reasons more than anything, but what we end up getting, and I'll change the colour for this, is a nice graph that looks, I'll just put some coordinates actually. So what we got, 2, 2, 6, 6. So you can see the graph will kind of go like this. So it'll look like a U, or an N shape. The graph will look something like this, and then all we need to do to find out the values of x is see where they cross the x-axis. So that will be this point here and this point here, and there are two values for that, and in this case x equals -3 or -2, and you can see that from there. So basically using a graph is it's quite easy to do. Find out all the coordinates, plot the graph, find out where the graph actually crosses the x-axis, and then they're the two values. Again, they will correspond the same with the factorizing method that we already done earlier on, or the equation, or completing the square. But the graph work is not quite as accurate. So that completes how to solve a quadratic equation using the various techniques. Thank you very much. Thank you very much. Laura, so here's a single bracket expansion. Are you happy to give that a go?
Yeah. Would it be 6x plus 5?
No, actually, it's not quite that. Not quite right. Do you want to give it another go?
Oh, was it 3 times 5 as well?
Yeah, 3 times 5 as well.
So it'd be 6x plus 15.
Yeah, perfect. Well done.